Hi everyone. Today we are going to look at parameterization of functions. It's a topic we started a couple of days ago, so we're still looking at solving some problems from this very topic. We explain what parameterization means, parameterization of a function, what it means. We explain all that. What is left now for us is to solve problems and see how this idea is being conveyed. You have a question here, and this question says, find a Cartesian equation for the parametric equation x equals t minus 2, y equals t to the power of 2 plus 1, and you are given the interval, the range of this t value. T could be seconds, it's the time, between minus 4 and 4. T is equal to or less than, is equal to or greater than minus 4, but is equal to or less than minus 4. So let's see. And we are asked to give our answer in the form y equals f of x. Then the B part says find the domain and range of that function f of x. So whenever you are given an equation in this parametric form and you are asked to more or less convert this equation into a Cartesian equation, xy plane, that's what it means, Cartesian, x and y. So more or less you are trying to reduce the variables here from 3 to 2. You have x, t, y. It's 3 variables. X, t, y. 3 variables. That is the parametric equation. But what they want you to do is to reduce these variables to only 2 so that they can fit in the xy plane or in the Cartesian coordinates. And you find the Cartesian equation. Okay, let's start. So how do you go about that? We want to get rid of t, because t is the parameter here in this equation. This t they introduce is the parameter. So we want to get rid of it. And then we are left with our x and y. So from this one here, you have x equals t minus 2. We want to make t the subject of the formula. So this now will become x plus 2 equals t. From this one, we bring the t over, the sign changes, so x minus 2 equals t. Now, we know what t means. T is x plus 2. Now let's put it in our equation here. Y equals t squared plus 1. We already know if this is equation 1, and this is going to be our equation 2. So we already know what t stands for. T stands for x plus 2. So we now substitute the value of t into this equation here. Y equals t, which is now x plus 2 to the power of 2 and then 1. Now the equation is in a Cartesian form. So the first part is being answered. F equals f of y equals f of x. So this now is y equals f of x. We only have x and y variables here, the independent and dependent variables. Y f, x and y. So the first part of the question is answered. Now, because you want to get rid of t, of t from this parametric equation, we have a value here. The values of t are given here between minus 4 and 4. We also have to get rid of this t here and replace it by x, so that we get the value of the x on the x coordinates, x-axis. So because t is already, we know it to be x plus 2, you have here, I'm writing here, I want to draw the graph there. That's why we want to go that side. You have here minus 4 less than or equal to t, and you have this t is greater than t is equal to minus 4, or t is greater than minus 4. But here t is less than minus 4, or t is equal to 4. But we know from here that t is equals x plus 2. So we now have minus 4 x plus 2. We replace t by x plus 2. Yeah? So what do you have here? These are inequalities. We want only x to be here in the middle, as t is only here. We want only x to be here. So if you want to take these two on this side, what would it be? It will be minus. Whatever you take it, you bring it here, it's minus, because it's plus here. You bring it here, it's minus. So now you have minus 2 minus 4. That gives you minus 6. Minus 6 is less than. Now, mind you, it's x only here now. We still put our inequalities. So these two, because of this inequalities we have, it will go there and it will come here again. So now 4 minus 2, this will be 2. So these are the new values we got for x when we got rid of t. So what is this value here? This is our domain. Before, when we were using the interval here for t, it was minus 4 plus 4. This was our domain in the Cartesian, in the parametric form. Now we are going to the Cartesian form. This is our new domain, minus 6 and 2. X is greater than or equal to minus 6, but less than or equal to 2. So we got what we want. Now what do we do next? We plot our graph. Because our graph will make us see the range. We can get it from here, but I want us to plot the graph so that we can see how the range is being calculated. This is the domain. We found it here. This is the domain. Correct? So now let's plot this graph. We are not going to do anything to this graph. Y equals x plus 2 all raised to the power of 2 plus 1. Because when you do quadratic equations, if you have something like this, it's good for you to plot a graph. Very easy. This is like you have factorized the equation in the vertex form. What you have here, this one you have here is like when you have your equation equals to y equals x plus h squared plus k. This is what is represented. Yeah? This is the vertex. These two values give you the vertex of the equation. So let's see how it goes. So now let's plot this graph. We know it starts from minus 6 to 2. We have, when you want to plot this graph, you want to plot this graph, and you are looking at this formula. This formula, sorry, should be minus h, not plus. Should be minus h. It has minus h here. Here you have plus 2. Yeah? So when it is plus here, in your graph, it's going to be minus. If this was minus, when you are plotting it, it's going to be positive. Yeah? Because you have minus h here equals 2. If you compare this and this. So therefore, h is going to be minus 2. This is the standard formula. So whatever you have inside here, you just equate it with the sign. Minus h in this case is equals to 2. So therefore, h is equals to minus 2. You want positive h. Yeah? So it's telling us this is the positive side is 2, 1, 1, 2, 1, 2. And negative side 1, 2, 3, 4, 5, 6. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Let's say this is 1. We're going to find the range, we don't know. So which means we're having our h is minus 1, minus 2, sorry. And our k is 1. You don't change the sign for k. What you have here is what you put. It's only this one that has the bracket that you do something with. This k is 1, it's positive. So our k, if this is 1, 2, 3, 4, this is our y-axis, x-axis. So k is 1, positive y, and h is minus 2. So 1 and minus 2, they meet here. So this is the vertex of the equation. This vertex means the turning point, maximum or minimum turning point of a graph of all these polynomial functions, what we call a vertex. So we have that. Now, when you want to plot a graph, certain things you consider. Where does this graph intersect with the y-axis? Where does it cut the y-axis? So if you look at your function here, y equals x plus 2 all squared plus 1. So how do you know where it cut the x-axis? The y-axis. It cut the y-axis at the point where x is 0. So if x is 0 here, you put y equals 0 plus 2 to the power of 2 plus 1. So 0 plus 2 is 2. 2 to the power of 2 is 4. So 4 plus 1 is 5. So it cuts the y-axis at 5. So here. So now our graph will go like this. So because we have 2 here, we should also have 2 here, because the vertex divides, more or less the vertex is like a mirror. It divides the graph into 2 equal halves. So because it's 1, 2, we also have 1, 2 here. So if you do like this, and then like this, so it's gonna be, oh, sorry, my drawing is not correct. Correct. My graph was not. Yeah? So this is why it's called the y-axis, minus plus 5. So this is your graph. So now, we've plotted this graph. We're asked to find the range of f of x. So how do you calculate the range? The range is the value of the y-axis, where the graph goes with the y-axis. That is the range. From where it starts, from where it goes. So already you can see that this, from this formula here, this is our graph. Whatever we have here for x, because it's squared, it will never be less than 1. We have a positive 1 here. Whatever value we put for x, even if we say minus 10, it's going to be minus 10 plus 2 minus 8. Minus 8 squared is a big number now. So because this is squared, that number will never go below 1. So therefore, our graph starts, the range now we are doing, it starts from 1. Yes. From 1 to where? From 1 to where? to where y is greater than. Y is greater than. No, it starts from 1. So y is greater than. Y is greater than 1. Sorry. Start from 1. Y should be greater than 1. To where? To where now you see our range is -6 x greater than or equal to -6 less than or equal to 2. So how do you find the range in this case? How? Where is that? Where is this sound coming from? Okay. So the range, if we put the value of x here, we say we put the value of 2. Value of x, 6. So this is going to be 4. If you put -6 here, -6 plus 2, -6 plus 2, you're going to be -4. So -4 squared. -4 squared, because it's squared, is positive. So it's going to be 16. So 16 plus 1 is 17. If you put 2, you're going to be 4 plus 4 squared. If you put 2 here, it's going to be 2 plus 2 is 4. So 4 squared is 16. 16 plus 1 is 17. So our range is 17. So this graph will continue 17. So the range is 17. So I should not have put this. It will go up to 17 here, where this reaches 17. So this is the range. Thank you for watching. Why this thing